We're going to take a look here at solving absolute value equations and inequalities. Essentially, we're just going to take and put both of those things on the same worksheet. So we're combining the last two sections that we've kind of been looking at here. So you have to decipher whether it's an inequality or an equality as you're going along. But hopefully you'll see that, that these are extremely similar in the way that we solve them. And you just have to pay attention to some wording that happens in between. So number one, we've got is 2 a solution of absolute value x minus 8 equal to 6? So the question is that a domain? Is that number in the domain? Is that a number that will satisfy this equation? Is it an input that will give me that output? Okay, and so I want to know if I plug in the 2, is it going to work? That's the bottom line. So 2 minus 8, I want to know if that comes out to be, after I do the absolute value, if it comes out to be 6. So then this is absolute value of negative 6. Absolute value of negative 6 is 6, not absolute value of negative 6. Absolute value of negative 6 is 6, and that equals 6, which is true. And so I say, yes, that comes out to be correct as I go through and attempt to plug the problem in. Okay, so yes, that's the solution. Number 2. Now, this is an equality. Okay, I want to make sure that it's equal to a positive number, and it is. So now I can split it to set up the absolute value, get rid of the absolute value. So I'm going to do whatever's inside the absolute value equal to the negative side to the left, and whatever's in the absolute value equal to the positive side to the right. So the number that's in front of the y here is a negative 1, so I'm going to divide by that lazy 1. Negative 6 divided by negative 1 is 6. Divide by negative 1, divide by negative 1, y is equal to negative 6. Then all these equations have an and in between. So the answers to this are y equals 6 and y equals negative 6. Number 3, we've got absolute value. It's not by itself, though, so I have to get it by itself by adding 3 to both sides. So I get absolute value of 8 minus y. 3 plus 1 is 4. Now the absolute value is by itself, and I can go ahead and split it. So I do 8 minus y equals the negative of 4, and I do 8 minus y is equal to 4. I'm going to subtract 8 from both sides. Negative y is equal to negative 12. This is a negative 1 in front, just like it was before, so then y is equal to positive 12. Same steps on this one. Subtract 8 from both sides. There's a negative 1 in front, so I divide by that negative 1, and y is equal to positive 4. There's an and in between here. So my two answers are 12 and 4. Those are the two numbers that I can plug in to make this equation come out to be true. Number 4, we're looking at an inequality here. The absolute value is by itself, but the problem is that it's equal to a negative number. That's perfect, because that allows me to do nothing, because I can't take an absolute value and have it come out to be negative. That's a no solution problem. Number 5, though, absolute value is by itself, and it's not a negative number, so I actually have to solve this one. 2 minus 9x. I'm going to do the negative side over here, so I'm going to switch the inequality, and then 2 minus 9x greater than or equal to with that positive 20. Solve this, subtract 2 from both sides, negative 9x less than or equal to negative 22. Divide by negative 9, divide by negative 9. X, I divided by a negative, so this has to be greater than or equal to, and 22/9 is perfectly fine as a fraction. I'm not going to divide that out, so I leave it as 22/9, but the negatives can cancel each other out. The second one I'm going to do here in a different color because I'm going to run out of room otherwise. Negative 9x greater than or equal to 20 minus 2 is 18. Divide by negative 9. Divide by negative 9. Because I divided by a negative, I have to flip the sign. This is a greater symbol, so great or. Okay, greater, this is an or symbol. So I have an or in here. So are there numbers that are bigger than 22/9 or less than or equal to negative 2? And yeah, because I've got that or in there, there's plenty of solutions that that will work out just fine for that one. And the last problem here, we've got the 3x minus 5 plus 1. It's not, absolute value is not by itself, so I got to subtract that 1 from both sides first. So 3x minus 5 and the absolute value less than 6. Now the absolute value is by itself, so then I can go ahead and I can split this into 3x minus 5. Switch it to greater than and make the answer negative. 3x minus 5. Leave it and leave it. Add 5 to both sides. 3x greater than negative 6 plus 5 is negative 1. Divide by 3. Divide by 3. X is greater than negative 1/3. Even though the answer is negative, I didn't divide by a negative on both sides, so I'm good to go. I don't have to do anything else with that. I don't have to flip the sign. Add 5 to both sides over here. 3x is less than 11. Divide by 3, divide by 3. X is less than 11/3. Ah, perfect. It's a good fraction. That's fine. I've got a less than. That's an and. Less than. Less than. Less than. Less than inequality. So I want to know, are there numbers that are bigger than negative 1/3 and less than 11/3? And the answer to that is yes. There are plenty of numbers that are bigger than negatives and less than positives. And so I go through, solve the problem, making sure that I realize with the inequalities that I have greater or and less than, and go through and take your time on these, right? Finish up the rest of the worksheet, making sure that you're understanding and asking questions as you're going along.